Santa, we've all heard of the guy. Big, red, fat, quite possibly invented by the Coca-Cola Company. Anyway, we're not here to talk about that today. We're here to talk about how Santa quite possibly just ignores the laws of physics. The Earth is pretty big, as in 510 million kilometers surface area big, which means that Santa obviously has to utilize time zones to get the job done efficiently and just in a reasonable time frame. And since he gets the job done in one night, we'll give him 24 hours to go across the entirety of the Earth. And since there are 24 time zones on the Earth, we divide the surface area of the Earth by 24 to get about 21 million, which means that Santa is moving 21 million kilometers an hour. But of course, there are a variety of things wrong with this measurement. For one, Santa doesn't have to move over the entire surface area of Earth, only the land, which is significantly less, only 30% of the surface area. Secondly, time zones aren't all the same size, which means he'll be spending a different amount of time in each one. And lastly, more people just live in different time zones. There are different amounts of people, which means he has to deliver more presents in different time zones, which means that he's going to be spending longer in certain time zones, but barely any time in other time zones. Taking all of this into account, I calculated Santa's route to be about 300,000 kilometers, which is much less than the 510 million we were working with earlier. Dividing this value by 24 gives us about Mach 10, which is, again, much less than 2% the speed of light. Ignoring how Santa got to those speeds in the first place, we can now look at all the interesting effects physics has on him for going Mach 10. As I said earlier, Santa's speed is around the ballpark of 12,500 kilometers an hour, or about Mach 10. Now we're going to be very basic and assume that Santa's sleigh is a cylinder, because we're going the front slope of it, and it's made out of pine wood. We're ignoring the reindeer for now, but I'll explain why in a bit. Anyways, Santa's sleigh travels at 60,000 feet, and I estimated, very generously, that it's about 2 parts wood for every 1 part air. This gives us a general density of 334.09 pounds per cubic foot. I also concluded that the drag coefficient for Santa's sleigh is about 0.5 because it's somewhere in between a sphere and a cylinder and definitely nowhere near as aerodynamic as something like an airplane. And after putting all of those values into a drag equation calculator, we get an overall drag force of 29,760,192 newtons, which, yeah, that's a lot of force. You know what that means? It means that the reindeer are constantly putting out this amount of force, plus more, just to keep the sleigh in the air. This isn't even taking account the presents or the reindeer's own mass. See how stupid this is? And if the sleigh is made out of aluminum, it's even worse! And in the aluminum calculation, where a fifth of the material is aluminum, we get 49 million newtons of drag. So, what's happening is the reindeer are putting the amount of energy of 100 kilograms of TNT for every meter that they're going, and we're going 3 kilometers a second, so it's 3,000 meters a second. So every single second, the reindeer are putting as much energy as a nuclear bomb blast into the atmosphere. How are we still alive? And this is just without the presents. With the presents, it's several SAR bombas going off in the atmosphere every single second. How? And somehow I wasn't the only person to do these equations. There's something on the University of Birmingham's website that has similar calculations to what I'm doing, so I'll share some of them with you. So according to this lovely article, it says that NORAD says that Santa travels at 6.25 kilometers a second over oceans, and only 1.4 kilometers a second well over cities like the UK. Which honestly means that my speed for Santa, which of course was just the average, was actually super close to the actual speed, so pretty cool. And also, here's why I didn't talk about note of the reindeer. It says that reindeer have pointy snouts and are just really aerodynamic. When having 9 reindeer in a formation helps to efficiently cut air because it acts sort of like an edge, like pushing the air away like a wedge, you know. But also that means that we now know why Rudolph's nose is red. Because he is experiencing the full force of the heating and friction of the air and just the compression of the air, that comes from traveling at 3 kilometers a second average, and also, 49 million newtons of drag, it's nothing for him. And also, yes, I am an American using the metric system, but guess what? We Americans over here in John Freedom America land, we use the imperial system, which guess what? It's a British system. The metric system is French. The English are using a French system, and I use the metric system to insult the British. Thank you, see you next year.